Hello, this is the Chapter 6 review video. Let's get you ready to take that Chapter 6 test. So question number 1 asks, what's the probability of an event that will definitely occur? Well, that is going to be 1. And the reason why that is because probability is a scale between 0 and 1. So certain to occur and never going to happen. So question number 2, what's the probability of an event that is known to be impossible? That would be 0. Okay, so the next question gives you a whole lot of information that you need to organize in a two-way table. So let's see what we can do. It says a statistics class contains 12 males and 9 females. So it looks like total males would be 12 and total females will be 9. So took care of that information. Then it says 4 of the females, so this is the female row, are psychology majors. So I have to put 4 here. Now, if I have 4 psychology majors, that means 5 plus 4 is equal to 9, okay? The remaining females are sociology, obviously. 8 of the males are psychology majors. So where's psychology? 8 of the males. So what plus 8 gives you 12? 4. It says create a two-way table. All right, that's what we're doing. Okay, so if I'm going to add up the sociology majors, I'm going to get a total of 9. Psychology majors would be 12. And then everybody all together is going to wind up being 21 total. Okay, so this next question says find the probability of selecting one student at random. So one student, and we're going to have to figure out who is female or a sociology major. So we've done this recently. So let's write this in notation. So we're looking for female or sociology. Now, when I taught you the OR formula, you have to do the probability of the first event. So that would be probability of a female, probability of the second event, which would be sociology. But then you have to subtract the probability of the overlap or both of them being female and sociology. So look at your two-way table, look only for females, and we have 9 females, but we have 9 out of 21. How many total sociology do I have? I also have 9 sociology, so 9 plus 21. Here's the thing, you have to subtract the overlap. So do we have any females that are also sociology majors? Yes, we do. That is 5. Okay, so we're going to subtract 5 out of 21, and that's going to give us 9 plus 9 is 18. Subtract 5 gives us 13 out of 21. Final answer. So this next question starts out with that very special word, given. So if you see that it says given, that means it is conditional probability. So I'm going to write this out using a formula also. So given that the student is a psychology major, given is always right here, or that's your condition. Find the probability that the student is male. So I'm going to put male. So I'm doing this because of the word given. So what you have to do is you have to break this down into the probability of both of them occurring divided by the probability of that condition. Okay, in this case, our condition is psychology. So I'm going to replace that with psychology. I'm just going to put PSY. Okay, how many do we have that is male and psychology? Male psychology, 8. So I have 8. Out of how many is just psychology? So 12 total psychology, and then 8 out of 12 is going to wind up being, 4 to 6, 2/3. Yep. Okay, so for this next question, I'm going to have to kind of jump back and forth here. So what I want to do first is start with the common area, females and sociology. So females and sociology, that is 5. So that is in common. and I had 9 total females. So that means I have 4 females here, and I had 5 that's in common. So how many total sociology did I have? I had 9. So I have to have 9 in the circle of sociology. So 5 plus 4 gives me 9. Now here's the tricky part. If they don't belong in this female category, then this is going to be in the male category. So what I'm going to do is I'm going to look up here temporarily and figure out how many males we had. So I have 12 total males. Now that is not necessarily the number that's going to go in this little empty box down here, okay? So I know that I have 12 floating around outside this circle here. How many males are in sociology though? How many males are in sociology? I have 4 males that are in that sociology. So if I have 12 males here and I have 4 in this sociology circle, then that leaves me 12 minus 4, which gives me 8 left over in this Venn diagram. Okay, so question number 4, a calculator is programmed to generate whole numbers between 1 and 15. So basically what that means is you've got 1 all the way through 15. So let's make a quick list. Okay, now you have to figure out the probability of selecting one of these numbers that's prime. Now I know it's going to be out of 15, but I need to count how many prime numbers that I have. So how many are prime? Prime is going to be any number that has only 2 factors, and 0 and 1 do not count. So I'm going to immediately get rid of 1. So anything that has more than 2 factors, I'm going to mark out. Those are called composite numbers. So 2 only has 2 factors. It's 1 times 2. So that's prime. 3 is 1 times 3. Now 4, I'm going to mark it out because it's 1, 2, and 4. 5 is prime because 1 times 5, that's it. 6 is composite because it's got a 1, a 2, a 3, and a 6. So do you see what I'm doing here? Okay, 8's composite, 9's composite, composite, 11. 11 only has 2 factors, 1 in itself. 13 is prime. Okay, everything else is composite. So I've got 1, 2, 3, 4, 5, 6 prime numbers. And if I simplify that, I'm going to wind up with 2 out of 5. Okay, question number 5 is asking about independent events. Now remember, independent means that one does not affect the other event. Okay, so it doesn't matter what you do with the first thing that you do, that it doesn't affect the second thing. So selecting a floor number out of 10 floors and then selecting a room on that floor, that is absolutely conditional depending on the hotel floor that you pick. So this is out. Okay, choosing 2 marbles from a bag without replacing it. So if you don't replace it, the second time you pick a marble, it's going to have a smaller sample space. That is dependent. Rolling a die 2 times. If you roll a die the first time, it does not matter what you roll the second time. One does not affect the other. This is what you're looking for. That is independent. Choosing 2 different months. So if it says different months, that means if you choose 1 month, you can't choose it again. So that is now considered dependent because your sample space has changed. Okay, question 6 is very much an independent kind of issue. It says you roll a 6-sided die 1 time. You roll it 1 time, you get a 6. How many more times must you roll the die to ensure that you roll a 3? Are you ever guaranteed to roll anything on a die? You are not. So there is no way that you can predict exactly how many times that you need. So it is absolutely impossible to know. And this one doesn't make sense because it is totally possible for you to roll a 3. You just don't know how many times it's going to take to make that happen. So question 7, that is one of those fundamental counting principle things. Like you could do a tree diagram with this. It says Lucas has 10 different shirts and 6 different pairs of pants in a drawer. How many different outfits can he choose? He wants 1 shirt and 1 pair of pants. So if you've got 10 different shirts, that means you've got 10 different possibilities. So if he picks a pair of pants, how many possibilities does he have for that when he has 6? So the rule states that if you have 10 outcomes and another 6, just multiply them out. So that would be 60 total outcomes. Okay, so in my opinion, I think question 8 is one of the more difficult questions on your review. What you need to do is consider the fact that you are having two events. You're trying to figure out the probability of choosing a red hat and white shoes. So what is the probability of choosing a red hat? Well, what you got to do is you got to think, you have 2 red hats out of a total of, so that's 2 plus 6 plus 4 is going to be 12 hats. So you have 12 total hats, but 2 are red, okay? The next thing you're going to do is you're going to multiply that times the probability of white shoes. So you got 6 pairs of white shoes. So white shoes out of a total of 4 plus 6 gives you 10 total. So you got to be really careful with that. So 12 times 6 is going to give you, 2 times 6 is going to give you 12. And then 12 times 10 is going to give you 120. And that's going to simplify to 1 over 10 or 0.1, which is this. Okay, question number 9 says that you got a bag that has 20 ping pong balls. They're labeled 1 to 20. So I'm going to write down that I have a total of 20. Oops. And then it says 3 of these balls. So you're going to pick 3 out of the 20. And we're trying to figure out what's the probability that the balls are selecting in that order. So order usually refers to either a permutation or a combination. So you've got to figure out, does the order matter or does it not matter? And it's asking specifically that the balls 1, 2, and 3 are selected in a very specific order. So this is a permutation. So you're going to put a little 20 and then a capital P, and then you're going to pick 3 balls out of that. So let me take my calculator and figure that out. So we're going to do 20, hit probability, permutation, and we're picking 3 of the 20. So it's going to give me 6,840 total possibilities. And I want specifically those balls in that order. So that means I have 1 out of 6,840 for a probability, which is choice D. Okay, question number 10. If you read the whole thing, you get to where it says the probability that you're looking for a randomly selected member of the marching band. So you're automatically looking for somebody in the marching band. That is a condition. And it doesn't use the word given, so you have to be really careful with that. So I'm going to start out saying probability. I'm going to put my condition line here, and I'm going to say that they're in band. And then it says, is also a member of the theater. So what we're going to do is we're going to figure out the probability of them being in both divided by the probability of the condition, which is band. Now, you can just write down the total of each. So how many people are in both theater and band? It says 25 are in theater and also band. So I've got 25. And then how many are just in band? It says a marching band has 75 members, which is 1/3. Okay, question 11, if you notice, is worded very similar to the last question. It says, what's the probability that a randomly selected member of the club, the science club, is also in math? So I'm going to write the probability that they are in the science club is also in math. So all you have to do is you have to find the probability of both divided by the probability of your condition, which is science. So how many are in both? We have 20 that are in both science and in math class. How many are in the science club? We have exactly 60. So 20 out of 60 is going to reduce to 1/3, which changes to 0.33 or 33.3%. All right, so question number 12 is trying to figure out if you know the difference between a dependent and an independent event. So dependent means that it is affected by the other events, and independent means it is not affected. So if you have a bag with a whole bunch of pens in it, somebody picks a pen and then they replace the pen. So if they take it out and they replace it, are they really changing that sample space? No, they're not. So one draw does not affect the other, which means that it is an independent event. Okay, next question. Personally, again, I feel like this is probably one of the more difficult ones. So you just have to really pay attention to the wording in this one. You've got a box. It contains 21 marbles of the same size. Okay. 7 of the marbles are white, 4 are black, 10 are green. So if 2 of the marbles are randomly selected from the box, so we have first marble, and then we have the second marble. So I kind of have like 2 events going on here. I need to figure out if it's independent or if it's dependent. It says, what's the probability that the first marble is white and the second is green? Okay. Given that the first marble is not replaced, that should say replaced. So if it's not replaced, that means that this is dependent. So our sample space is going to shrink when we pick that second marble, okay? So here's what we need to do. We need to focus on what the total count is for each selection. So it says I've got 21 marbles of the same size. So I've got 21 marbles in that first pool. If I take one marble out and I don't replace it, how many do I have left? I have 20 total for that second pool. Okay, now let's talk about what we want. Now it says we want the first marble to be white. So how many white marbles are there? We have 7 are white. So I'm going to put 7 up here because that's how many white marbles I have. Now, if I pick a white marble, does it affect the fact that I'm going to want a green? No. So I'm still going to have, how many green are in here? 10. So I have 10 that are green. So assuming that I pick one of the white marbles here, I'm still going to have 10 in that second group here. So let's multiply this together and see what we get. Okay, I just typed that in my calculator and I wound up with a 1/6, which is the correct answer. And there you go. Just let me know if you've got any questions on that one. All right, question 14. A shop orders personal size pizzas with a choice of 12 total toppings. Olivia wants 3 different toppings on a personal pizza. How many different pizzas can she order? So this sounds like either a permutation or a combination kind of problem. The question you need to ask yourself, does it matter how she orders those 3 different toppings? So if she wants like pepperoni, onions, and black olives, as long as all 3 of them made it to the order, it doesn't matter which one she said first, which one she said last. So they're all 3 kind of grouped, and none of them are more special than the other. So this means that this is going to be a combination. So I'm going to do 12 total toppings, and I'm going to choose 3. The order does not matter. You just know that that pizza is going to have those 3 toppings on it, and that's all you care about. So let's type that in our calculator. 12, choose 3. So 12, choose 3, 220 possibilities. All right, next up, if you are arranging things and it's asking you how many ways they can be arranged, that is automatically going to be a permutation. You need to count how many letters we have. We have 1, 2, 3, 4, 5, 6. It's a permutation because the order matters because you're arranging them in a very specific way. And then it says how many different 6-letter arrangements can she make if she's using all 6 letters. So I'm going to do 6, pick 6, use your calculators, 6, pick 6, and I get 720 possibilities. So that's basically saying that you've got 720 different ways to rearrange the letters P-L-A-N-E-T. All right, so be aware of question number 16. Several of you misread it when we took the quiz the other day. So this one says a coffee shop offers a small, medium, and large meal. So your first choice is the size. So it's either going to be small, medium, or large. So that is 3 different options: small, medium, large. Now the next choice you have would be an actual type of coffee. So we're going to do type of coffee. How many do we have? We have 6 different types of coffee. And then the next choice that you need to make would be what pastry that you want. So we have 4 different types of pastry. So all you have to do is multiply those numbers together. So you're going to wind up with 3 times 6 times 4. 3 times 6 times 4, which gives you 72 total outcomes. Okay, we got a two-way table here. I love two-way tables. A survey of 40 randomly selected people were taken. Each person was asked 2 questions. What is the average number of hours you sleep each night? And would you like to get more sleep? Okay, so it's just giving us a kind of background of the information on our two-way. Based on the data collected, what is the probability that a person would like to get more sleep given, oh, there's that keyword again, given. Given is a condition. So if you were going to think about this as a conditional probability, you need to write it in this form. Given that the person sleeps 7 hours or less, so I'm going to say 7 hours or less. So what is the probability that they would like to get more sleep? So they would like to get more sleep. Okay. Now, you can use the formula if you want to, but if it's a two-way, you can just simply ignore everything except for the condition. So what is our condition? It is 7 hours or less. That right there, that's what I'm worried about, okay? Ignore everything else in the table. So what's the probability that they want to get more sleep? So do they want to get more sleep? 20. So the top number is going to be 20, but it's going to be out of a total of 25 people. Okay, you are going to have to simplify that. Actually, if you look over here, you need to change it to a percent. So 20 divided by 25 gives you 0.8 or 80%. Now, I'm going to show you really quickly how you would do this with the formula. It is a little bit more difficult though. So you're going to do the probability of them both divided by the probability of just 7 hours or less. And guess what happens? What's the probability of them both happening at the same time? It is 20. Okay, 7 hours or less would be the total here. That would be 25. So you get the same exact thing if you use the formula. So it's really kind of up to you what you want to do. Okay, in this next question, you have no choice but to use the formula. If it doesn't give you a Venn diagram or a two-way table, you're out of luck. So you're going to write this down, the probability of A given B, and you need to translate that into the formula. You have to do that. So you have to do the probability of them both divided by the probability of the condition. The condition is B. This gives you the information that you need. This means both, okay? So A and B is 0.12, and you're going to divide that by the probability of B, which is 0.23. See, they give you extra information in here just to see if you know what you're doing with that formula. So I'm going to divide 0.12 by 0.23. And we get about 52%. There you go. You have to know the formula. Now the formula is on the formula sheet, so you don't have to have it memorized, which is awesome. Okay, next question. You roll a 4-sided die and you get an even number 6 times in a row. It is even 6 times you roll that die. Therefore, it's more likely that you're going to roll an odd number on the 7th. Absolutely not. One roll of a die has absolutely nothing to do with the next roll. I don't care if you roll it 100 times in a row. One roll does not affect the next. So this is absolutely false. Okay, this one is very specific to experimental probability. So experimental is based on an experiment. And this person over here tossed a coin 20 times. So if you're going to find the probability, it's going to be out of 20. They had how many? They had 8 that were heads. So if you're trying to figure out the probability of tossing heads, you have 8 heads and you have 20 total tosses. And you're going to just reduce that. So that's going to be 4 over 10, which is 2 over 5. You can use your calculator to do that. So you get B. Okay, last one. This is geometric probability. I think it's the last one. Yep, it is. Okay, so it says you throw a dart and it's equally likely to hit anywhere inside the square board. What's the probability that you're going to score exactly? That should say exactly 10 points. So what you're going to do is you're going to figure out the area of the 10 points, and you're going to divide that by the total area. Now, the total area is really easy. Total area is just length times width, and it's a square, so it'll be 6 times 6. So the length times the width, 6 times 6, which is 36. Okay, we got the denominator out. The area, 10 points. Now, this is a little bit more complicated. So you actually have a 4 by 4. So you're going to start with the length times the width of the yellow, but then you have to subtract the length and the width of the red. So this is yellow, and this is red. So the yellow one is 4 times 4, and then the red one is a 2 times 2. So that was going to be 16 minus 4, which is 12 out of 36, which winds up being 1/3. And that is it. And just make sure you let me know if you've got any questions about anything in the video or on your study guide.